Bonding and grounding is my favorite subject. I don't even call it bonding and grounding. I call it the science of safety. If you learn what I am about to teach you, you will ace your bonding and grounding questions on the exam. I'm going to do it a little different than you think. We're going to start in the beginning of the book, then go to the back of the book, and work our way back to the front of the book, and then work back through it with our highlights. It'll make perfect sense when I do it. So the first place I would like to see you is at 250.4A5. Page 111, right-hand column, 250.4A5. I will read it to you. Effective ground fault current path. Electrical equipment and wiring and other electrically conductive material likely to become energized shall be installed in a manner that creates a low impedance circuit, facilitating the operation of the overcurrent device. Low impedance circuit, facilitating the operation of the overcurrent device. Well, correct me if I'm wrong, but when we just learned the jobs of our conductors, we learned that the equipment ground is responsible for the removal of impedance from our system. And that just said I had to create a low impedance system to facilitate the operation of this. So in layman's terms, you're telling me that my equipment ground is responsible for the operation of this overcurrent device? Yeah, I am. I get phone call constantly. Mr. Ring, we need your help. We got a 3-pole 277 breaker, it won't trip. Can you come over and look at it? And I go, no, I ain't gonna come look at it. They go, well, you said you loved us. I go, I do, but I ain't coming. They go, well. I go, go check your equipment ground. They go, what? Go check your equipment ground. We just said the breaker ain't working. I go, yeah, did you hear what I said? Go check the equipment ground. It's either broke loose or it's undersized. Call me back. Hello. Is it working? Yeah. What was wrong? It broke loose. I still love you. If it'll latch and it's making voltage, but it won't work, it's not the system. It's not the equipment, it's the equipment ground. Now I'll show you why. This is a machine cabinet. This is why machine cabinets aren't supposed to be worn. When we attach an equipment ground to this, the primary job is taking place. That's Mike Faraday's first work. Isolation of this metal so it can't take on current so you can touch it without getting hot. Primary job. But it goes one step further. When we attach that equipment ground to that cabinet, now we have a conductor for use. So if we put a motor in this cabinet to run some apparatus, we are under the constraints of Gustav Kirchhoff's law of the electric loop. So if we have a 30 amp breaker and a motor that requires 10 amps, and now it is operating some apparatus within that equipment cabinet. 30 amps are being provided, 20 amps are being consumed, which means that 10 amps are being magnetically drawn out on that grounded conductor. But the entire time that is going on, there is an ever-present field of cloud impedance inside this cabinet while it's running. And the job of the equipment ground is to evacuate that while it's running. And that evacuation, since impedance is a force of resistance, if it's not doing its job, it begins to use this steel to absorb the heat of the resistance. So this cabinet gets hot. And 20% of the loading on that motor is now being absorbed into that cabinet. So therefore, when that motor goes into distress, because some component of that apparatus locks up, this device just simply sits there because only 80% of loading is being absorbed and returned to this breaker. So now when that thing goes into distress and begins to burn up, that breaker goes, "You smell something? It's got that electric odor." It's not me. I'm good. And that machine burns itself up, and this never trips. And then the customer calls you and said, "You had a bad breaker. Burned up my machine. Didn't even trip." And we go to apologize. "Oh yeah, ever since COVID, everything's just been junk. I'm so sorry." There's nothing wrong with that breaker. Equipment ground broke loose. All that heat of loading is now being absorbed in that cabinet. That's why it's hot. Everybody's always making fun of me when I go to factories, do my investigations. Yeah, I'm an investigator. They'll call me, have me to come do one. I'm always running my hand down everything like this. They're like, "Oh my God, we've hired Rain Man." What am I looking for? Oh, that's a hot one. Give me an electrician over here. Open that up. It's either broke loose or it's too small. Now that heat of loading being absorbed by that cabinet. Now if that cabinet goes into distress, this can't read the heat because this can't absorb it. This reads the heat. This measures it. This absorbs it. This measures it. If 20% of it's going in that cabinet, what happens to this? It's not going to trip. That's why it's a true statement. If we don't create a low impedance circuit, this won't work. The bonding jumpers in the corners give us the uniformity. That even spreads it out more evenly. But the accumulation is still there. It's in residence. The bonding jumpers help, but without the proper size equipment ground, you're not going to evacuate it. It will stay in residence. This goes back to, and I don't mind sharing it, the way Faraday made his point. Faraday made this presentation to the Royal Society. And that in the day was roughly about 150 members of the Royal Electrical Society. And the way he did it was he went to a blacksmith and had them build him a metal box and had it put on the stage, and then put a wooden chair and a small table with a wine glass and some wine, and then climbed in it, sat down, and gave his bonding and grounding presentation to the Royal Society, while his helper energized that cabinet with the bonding jumpers and equipment ground to 4,000 volts, while he sat there and drank wine sitting in it and gave this presentation. That's how he made his point. And I'm sure there were a lot of side bets on how quickly he'd turn to popcorn. But that was how he did it. And that was where the bonding jumpers, to give the uniformity and the distribution, what it does is potentially makes it even so it doesn't accumulate in one area. But the equipment ground is responsible for the removal. Now there's one other condition. This is the book of General, chapter 1 through 4. We are able to build equipment by specification. Whenever we build equipment by specification, a bonding and grounding calculation is made for the equipment ground. So that is the exception to 251.22. Because if you are told that a piece of equipment is by design, that supersedes 251.22. You need to go to that piece of equipment, open it up, and look for the largest equipment ground and match it. Because the design engineer has done the calculation on the amount of impedance that would be present and has sized it to that calculation. And you will find out a lot of times it does not coincide with 251.22. I'll give you an example. So I had to go to a tube mill about a year and a half ago. And I was there for some safety issues, but as I was walking through, I saw a large extruder control cabinet that had 6 PLCs and variable frequency drives in it. And I noted that the cover was off of it. And of course, me being there for safety was the first thing I saw. And I was like, well, that's not right. That's not supposed to have the cover off. So I walked over and I looked at it. And when I did, I suddenly realized what was wrong. And the maintenance director walked up and he said, what's going on? And I said, well, what caught my eye was the cover was off of this extruder control. And he goes, yeah, he said that thing was supposed to be the most efficient thing we had. And he said, that thing's been nothing but trouble from the day it came in here. I said, well, how many PLCs you burning up? He said, what? I said, that's a question. I said, my best guess is you're probably losing what, about 2 or 3 a quarter? He goes, yeah. He goes, how'd you know that? I said, well, I know what's wrong. He goes, what? I said, yeah. I said, there's your problem, it's equipment ground. I said, don't blame your electrician. You told him to hook this up, and he went to 251.22. It's not a general piece of equipment. It's a design piece of equipment. I said, that's the correct equipment ground from 251.22, but I said, it's 2 sizes smaller than the design ground. I said, so now guess what? You got all this field of impedance that can't leave the cabinet. I said, you took the covers off because it gets hot as an oven. He goes, yeah, you're right. I said, well, when you took the covers off and it couldn't get rid of the heat there, the next weak link was PLCs. I said, you want to fix it? Real easy. Use that green as a pulling wire, put the proper size on it and pull the right size, same size as the one that's in it. It'll quit doing it and you can put the cover back on. Cloud impedance. The bonding jumpers just spread it out more evenly. Doesn't change anything. Field of impedance is field impedance. As long as that machine runs, there's always going to be a field of impedance. Not a dumb question. They help, but they give the uniformity. So now, whenever we look at a condition, this is a primary example of how this function is supposed to work, which is why when you find equipment that is overheating, don't go looking for some failure of something. Go check your equipment ground first, because it has to be the right size to remove that field of impedance, and it has to be connected. If we lose it, then that will take up resonance, and the first result is you will see a cabinet begin to heat up.